Okay, so number one, section 1.1, we want to determine whether this order pair 1, 9 is a solution for this equation y equals 2x minus 15. All right, so in order to do that, all we're going to do is write down our equation, y equals 2x minus 15, and we have this ordered pair 1, 9. What you need to be aware of is that the first coordinate of the ordered pair is the x value, the second coordinate is the y value. If you think alphabetical order, most things go in alphabetical order, and x comes before y in the alphabet. So that will help you remember the order. From there, we will plug in 1 for x, 9 for y, solve it, and see if those two sides come out equal. So y equals 9, so I'm going to replace this with a 9. X equals 1, and then we're going to minus 15. So we do 2 times 1, gives me 2 minus 15. So if I do 2 minus 15, when I subtract those, I have 9 equals negative 13. And as you can see, these two sides, the left and right side, are not equal. So this is not a solution. This ordered pair is not a solution. So is this a solution? We're going to say no. Okay, so while we're here, we're also going to go ahead and work problem number 2. It is a problem similar in nature, except this time we're going to be plugging in 2 different points and finding out if either of those are solutions. Okay, so the equation this time is 7a plus 5b equals 2. All right, first it wants us to use the ordered pair negative 5/7 and negative 4/5. Okay, so generally we have x's and y's. This problem has a's and b's. Again, I mentioned it goes in alphabetical order. That's the norm. So this would be considered the A, and this would be considered B. Okay, so don't, there's not really, that's the best way to make the connection. As you see here, y was in the front, and so these points were switched. But if you label the ordered pair in alphabetical order x, y, then we know x was the second point, y was the first. But if you try to do that same pattern, like plug the back number in the front and then the front number in the back, it doesn't match up here because they have it in a different order. So that's why I'm kind of making note that you go in alphabetical order. So we're going to plug these points in. We have 7 times negative 5/7. Okay, plugging that in for A. Plus 5. And then the B value was negative 4/5. And then we have equals 2. So we just plugged in the A and B. So what happens? We're multiplying and dividing by 7. So we can just cancel out the 7 here, and we bring down our negative 5. And then over here, we're also multiplying this by 5, but we're dividing by 5. So multiplication and division are opposites. So I'm going to bring down a negative 4. I could put plus a negative 4, or you can just write minus 4. It's better just to write the minus 4. And then this equals 2. When we combine like terms, negative 5 minus 4 gives us a negative 9 equals 2. These two are not equal. So this first order pair is not a solution. So we're going to say no, because after substituting A and B, it gives the result of negative 9, and that is not equal to 2. All right, and then part B, we have the second order pair, 0 and 2/5. So we're going to be using the same equation, but we're going to plug in 0 and 2/5. So I'm going to say part B, we have 7a plus 5b equals 2. And we're going to plug in 0 and 2/5. Same thing, this is A, this is B, so 7 times A, which is 0, plus 5 times B, which is 2/5, equals 2. All right, 7 times 0, anything times 0 is 0. Multiplying by 5, dividing by 5, they will cancel each other out, and you're left with the 2, so plus 2 equals 2. And then 0 plus 2 is 2, so we get 2 equals 2. And this time, both the left and the right side are equal, so this checks out. So yes.